Hi, I'm Dr. Jekyll. Today I'm going to explain about Chapter 1 Foundations in Discrete Maths about sets, logic, and algorithms. These are the topics that will be covered in this chapter. For this video, I'm going to explain about topic 1.1 sets. What is set? By definition 1, a set is a well-defined collection of distinct objects. So a set contains all objects that can be clearly determined. So what is object? Object in a set can also be called the elements or members of the set. There are two methods to list the elements in a set. So the first method is called roster method. So the roster method listing the elements by using comma within braces. So let us see the example 1. The set of all vowels, for example, is V equals to curly bracket A, E, I, O, U. For example 2, the set of odd positive integers less than 10 is O equals to curly bracket 1, 3, 5, 7, 9. So what is the meaning for each of the symbol? So suppose A equals to curly bracket ABC. So the A is the element for the set A. So we can use this symbol to represent that the A is an element of set A. So let's say we have another element which is D that clearly is not here. So we can write it like this. D is not an element of set A. Also, if you want to list all the elements that the number can be too big, so you can use an ellipsis, which is the triple dots here. So for example 3, the set of positive integers less than 100 can be denoted by this curly bracket here. So we know that if you want to listing all the positive integers that less than 100, not necessary for you to write down 1, 2, 3, 4 and until 99. Actually, you can just 1, 2, 3 and put the triple dot and you end with the last number. So the second method for us to list all the elements in a set is using set builder method. So the set builder method describing a set by characterizing its element and stating the properties. So the notation generally can be written like this. So you can explain this notation like this. A is the set of all elements X of S such that X satisfies the property of P. So if you're still confused, so let us see example 4. So the set of positive odd integers less than 10 can also be written as O equals to curly bracket X element of Z positive. So the symbol Z positive stands for positive integer. So such that the X is odd and the X is less than 10. So this is the set of all elements for positive integer, and this is the properties or the conditions so that you can listing all the positive odd integers that is less than 10. So you also need to know several standard symbols which denote the sets of numbers. For example, capital N stands for the set of natural numbers. So natural numbers such as 1, 2, 3 and so on. Z stands for the set of integers, inclusive of positive and negative integers. So you need to put the triple dots before and after and put -2, -1, 0, 1 and 2. And then if you want to listing all the elements, the set of positive integers can be used is capital Z positive. And also Q is for the set of rational numbers, R the set for real numbers, and R positive the set of all positive real numbers. So if you want to list down all the negative integers, you can use Z. negative. So definition 3, set A is a subset of set B if all elements of set A contained in set B. So for subset, we use this symbol, meaning that all elements in A must contain in B. So if not, we use this symbol. So for example, let x equals to a, e, I, o, u, y equals to a, I, u, and z, b, c, d, f, g. So by comparing all these three sets, so we write y subset to x because every element of y is also element of x. So y subset x means the element here must contain in here. But all elements in x not necessary in y. Y is not a subset to z. For y element, which is AIU, is not there. The next one is a proper set. So by definition 4, A is a proper subset of set B if and only if A is subset B and there is at least one element in B is not in A. So this is the symbol for proper subset. So A proper subset of B. So let us see example 6. So let's say we have x equals to AEI, y equals to AEIB. Then you can say that x is proper subset to y. So x AEI contained in y, but at least one element is not in x. So you can also use this notation x subset to x for any set that is subset of itself. Definition 5. Given sets A and B, so A equals to B, so you can simply write it like A equals to B if and only if they have same elements. So A equals to B, meaning A subset to B and B subset to A. So for example, 1, 3, 5 equals to 5, 3, 1. So the elements are the same, but the difference is the order of elements. But if we have 1, 3, 5 equals 1, 1, 1, 3, 3, 5, 5, 5, they still equal between set on the left and set on the right, because it doesn't matter if the elements are listed more than once, as long as the elements are the same. So for a set with no elements, you can refer to definition 6, that is empty set or null set. So the notation for you to write for a set with no element is this one, null or empty set. Any set must contain an empty set, meaning that the empty set is a subset of any set. So later I will show you the example. So by definition 7, let A be a set. If there is exactly n distinct elements in A, where n is a non-negative integer, then A is called finite set. So if not, it is called infinite set. So n refers to the number of distinct elements in a set. So if we know the value of n, meaning that we know how many elements in a set, that means we can call the set A is a finite. So if we don't know the n, meaning that this a triple dot in a set, that means the set is not finite, or we call it infinite. So for example 8, y equals to bracket 1, 2, and 3. So this is a finite set with 3 distinct elements. So P equals to red, blue, yellow also is a finite set. For empty set is also a finite set with 0 elements, because 0 is still a number. But for E, refer to the set of all even integers, is not a finite set, or it is an infinite set, because we don't know how many even integers they consider in this set E. So definition 8, let A be a finite set with n distinct elements. So the cardinality. So the cardinality or the number of elements is equals to n. So basically the same with what I just explained just now. So the way we write down or the notation for us to find the number of elements, make sure we use this symbol, cardinality. So if P equals to bracket red, blue, yellow, then cardinality of P equals to 3. Definition 9. Given a set A, the power set A is the set of all subsets in set A. So I introduced to you a new symbol, power set P bracket A. So how to use this symbol? So let's say you have this question, what is the power set of the set 0, 1 and 2? So to find the power set based on this element, so you can write like this. So power set of 0, 1 and 2 is empty set 0, 1, 2, 0, 1, 0, 2, 1, 2, 0, 1, 2. Basically, power set is for us to list down all the possible combination or possible subset based on this set. So don't miss out every single combination or every single subset. So for universal set is use this notation, capital U. So you can write U equals to set of all students in this campus. Now I'm going to explain on how to represent the relationships between sets by using Venn diagrams. So this is the Venn diagrams for the set X. So we have the universal set, which is this rectangle, and the set X, which is this circle. So the shaded is a subset for all elements in the set X.